discuss about the topic of DC and AC bridges. The bridges circuit are used of very commonly as the variable conventional element measurement of system and the produced by an output of from of the voltage level, that is change of the measure the physical quantity changes their provide of the accurate method of the measuring resistance, the inductance of capacitance value and enable of the deflection of very small changes, thus the quantities about nominal value of the importance of measurement system technologies because of the many transfer measuring physical quantities have the output of the express change of resistance, inductance of capacitance of the displacement of measuring strain gauge, which of very resistance of output. But one example for these the classes of transducer normally extensions of bridges by of the DC voltage and resistance measurement and by an AC voltage or the inductance capacitance measurement of both null and deflection type of the bridges. Exit of on the like manner of the instrumentations is general null type of mainly employed for the calibrations purpose, and the deflection type of the used of within closed loop automatic of control room scheme. The first one of the bridges DC bridges of the Wheatstone Bridge. Wheatstone bridges without the extensions commonly unknown of Wheatstone bridges as the from of zoning figure. There are four of bridges in the consider of the unknown resistance value. With two equal resistance value of R2 and R3, a variable of or variable of resistance of or variable resistance and value on to first on the voltage VI applied the across the point. AC and the resistance variable resistance of verified on to the measure the across the point of B of D is the zero. This is null point of usually of high sensitivity of galvanometer. The analysis of Wheatstone bridge is the current following through the I1 and I4 the zoning figure. Normally a high impedance of the voltage and measuring instrument used of current. The instrumentation is very small and the approximated of zero. The assume of the make the value with the maximum current is first one of the current is the I1 minus I1 is equal to of I3 and I2 equal for is equal to of I4. Looking at the ACDC of have the voltage applied across the resistance value is R2 plus of R3 and the Ohm's law. RU plus R3 is first one of the I1 is equal to V1 divided by RU plus R3. Similarly, both of A and BC of I2 is equal to V1 divided by RB plus R2. Is a similarity of the pattern circuit diagram of in the calculator of the voltage drop across A, D and AB. A and B, so first voltage AD is equal to I1 current is variable resistance is equal to V1 RU divided by RU plus R3 is equal to voltage AB is equal to I2 current variable resistance is equal to V1 RV divided by RV plus R2. By a principle of superposition is a output voltage is equal to is a voltage of BD minus voltage of VA plus voltage AD is equal to minus AB plus V of VAD is the output to voltage current is equal to value of first one A voltage AD is value V1 is RV divided by RV plus R2 plus V voltage 1 into the RU divided by RU plus R3. Null point also is the output current of null is direction of the 0 is equal to RU divided by RU plus R3 is equal to RV divided by RB plus R2. Is the inverting of both side of value equal for value of the R12 is R3, RU is the RB is actually of accurated of with the known value of because the derive of variable said the resistance value is mean of RU is also accuracy of value is the deflection of the DC value is the mean of output voltage is in the input voltage in the RU divided by RU plus of R3 value is a very non-linear with of the current negative positions of variable the value of the Wheatstone bridge is used of null directions of percent values. Okay, thank you.